Now to the next problem. Here we have an ice cream cone. Now the figure shows the cross section of an ice cream cone consisting of a cone surmounted by a hemisphere. The radius of the hemisphere is 3.5 centimeter and the height of the cone is 10.5 centimeter. The outer shell ABCDFE is shaded and is not filled with the ice cream. Now we are given that AE is equal to DC is equal to 0.5 centimeter and AB parallel to EF and also BC parallel to FD. Now we want to find the volume of the ice cream in the cone, that is the unshaded portion including the hemisphere, in centimeter cube. Also to find the volume of the outer shell, that is the shaded portion, in centimeter cube. Give your answer correct to the nearest centimeter cube. Now in this sum, first of all, in the figure, let us mark the point N as shown. Now we are asked to find the volume of the ice cream cone, that is the volume of the inner cone. Now we don't know the radius of the inner cone, nor do we know the height of the inner cone. So let's first find the radius of the inner cone. Radius will be EN, that is AN minus AE, that is equal to 3.5 minus 0.5, which is 3 centimeter. So now we know the radius of the inner cone. Now we have to know the height of the inner cone. Let us take triangle ABN and triangle EFN. Now these two triangles will be similar to each other by AAA test of similarity. Now we know if two triangles are similar, then their corresponding sides are proportional. So we can write FN upon BN is equal to EN upon AN. Now FN upon BN is 10.5 centimeter. Substitute that value, which is equal to EN, we have already found out as 3 centimeter, and AN is 3.5 centimeter. Now substitute all these values and find FN as FN is equal to 3 into 10.5 upon 3.5, that is equal to 3 into 3, that is 9 centimeter. So we have got the height of the cone as 9 centimeter. This is what we are talking about, the inner cone. Now the volume of the ice cream in the cone will be equal to volume of the hemisphere plus the volume of the inner cone, that is equal to 2 upon 3 pi capital R cube plus 1 upon 3 pi small r square into h. Now from here 1 upon 3 pi common, in the bracket we have 2 into. Now in place of capital R we substitute 7 upon 2. So we have 2 into 7 upon 2 the whole cube plus 3 square into 9. Simplify this further. 1 upon 3 into 22 upon 7 into 343 upon 4 plus 81. Now we further simplify the bracket to get 343 plus 324 upon 4. Now we further get 1 upon 3 into 22 upon 7 into 667 upon 4. Now simplify all this. We have 7337 upon 42. Now divide this to get 174.69 centimeter cube. So we have the volume of the ice cream cone as approximately 175 centimeter cube. Because we are told in the question, write the answer correct to the nearest centimeter cube. So we have 175 centimeter cube. Now for the second part, we are asked to find the volume of the outer shell, that is the volume of the shaded portion. So the volume of the outer shell will be equal to volume of the outer cone minus volume of the inner cone. That is equal to 1 upon 3 pi capital R square h minus 1 upon 3 pi small r square into small h. Here the heights will also be different. Now capital H over here will be 21 upon 2, whereas small h is 9 centimeter. Now 1 upon 3 pi common in the bracket r square h minus r square h. Substitute the values, we get 1 upon 3 into 22 upon 7 into 7 upon 2 the whole square into 21 upon 2 minus 3 square into 9. Further simplify this as 22 upon 21 in the bracket 49 upon 4 into 21 upon 2 minus 81. Now take the LCM in the bracket, we get 22 upon 21 into 1029 upon 8 minus 648 upon 8, which is equal to 22 upon 21 into 381 upon 8. We have 11 into 127 upon 28, which is nothing but 1397 upon 28, which is equal to 49.89 centimeter cube. Now again we need to round this off to the nearest centimeter cube. So we write the answer as 50 centimeter cube. That is, the volume of the outer shell is 50 cubic centimeter. Let us look at this topic from the board point of view. From this topic and the cone, there is just one question that comes in the board exam carrying 3 to 4 marks, and it is mostly in section B. Now, where can you lose marks in this topic? Always write down the formula you are using. Then also draw the figures wherever required in pencil only. Write down the correct units for the volume and the areas respectively, and also try and keep the calculations simple as far as possible. Now let us solve some board questions. We take the March 2003 board question, that is, a vessel is in the form of an inverted cone, its height is 11 centimeter and the radius of the top, which is open, is 2.5 centimeter. It is filled with water up to the rim. Lead shots, each of which is 0.25 centimeter radius, are dropped into the vessel. 2/5 of the water overflows. Find the number of lead shots dropped into the vessel. Now let's solve this sum. Here for the cone, we are given the radius capital R as 2.5 centimeter and the height h as 11 centimeter. Now for the lead shot, the radius small r is 0.25 centimeter. Let's draw the figure for this. We take the conical vessel, or rather the inverted cone, and we are putting lead shots in it, that is lead spears we are dropping in that. We are given volume of the lead shots is 2/5 the volume of the cone, because when the lead shots are put in the water, 2/5 of the water overflows. So we have volume of the lead shots is equal to 2/5 times the volume of the cone. That is number of lead shots into volume of one lead shot is equal to 2/5 times the volume of the cone. So from here we have number of lead shots is equal to 2/5 times the volume of the cone upon volume of one lead shot. That is equal to 2/5 into 1/3 pi r square h upon 4/3 pi r cube. Now cancel 3 and cancel pi. We have 2 into, in place of capital R, we write 2.5, and in place of h, we write 11. And in the denominator, in place of small r, we will write 0.25. So we have 2 into 2.5 the whole square into 11 upon 5 into 4 into 0.25 the whole cube. Simplify this further, we get the answer as 440. That is, the number of lead shots dropped in the vessel is equal to 440. Now let's take the second board problem, that is the March 2007 board question. It says the surface area of a solid metallic sphere is 616 centimeters square. It is melted and recast into smaller spheres of diameter 3.5 centimeter. How many such spheres can be obtained? Now in this sum, we are given the surface area of the bigger sphere as 616 centimeters square, and we also given the diameter for the smaller sphere as 3.5 centimeter. So the radius will be half of that, that is half of 7/2, that is 7/4 centimeter. Now, since surface area is given to us, we can find out the radius of the bigger sphere. Surface area of the solid sphere is equal to 4 pi r square, that is 616 given. So we have r square is equal to 616 into 7 upon 4 into 22. Simplify this further to get 7 square, that is radius is equal to 7 centimeter. Now we want to find out the number of spheres that can be formed. That will be equal to the volume of the bigger sphere upon the volume of the smaller sphere. So we have 4/3 pi capital R cube upon 4/3 pi small r cube. Now 4/3 pi cancels. We have capital R cube upon small r cube. That is 7 cube upon 7/4 cube. Simplify this to get 4 cube, that is nothing but 64. So 64 smaller spheres can be formed. Let's look at the brain map of this topic. Now we have seen what is a sphere, its volume and its area. And in the same way, for a hemisphere, for a spherical shell and for a hemispherical shell. Let's revise this at a glance. For a sphere, we have the volume as 4 upon 3 pi r cube and the surface area will be 4 pi r square. For a sphere, the surface area means you can say either the curved surface area or the total surface area. It is the same thing. Now for a hemisphere, we have the volume as 2 upon 3 pi r cube, the curved surface as 2 pi r square, and the total surface area will be curved surface area plus area of the base, that is 2 pi r square plus pi r square, which is 3 pi r square. For a spherical shell, we have the volume as 4 upon 3 pi capital R cube minus small r cube, where capital R and small r are the external and the internal radii of the two spheres respectively. We have the total surface area as 4 pi capital R square minus small r square. Now for a hemispherical shell, the volume will be 2 upon 3 pi capital R cube minus small r cube. The curved surface area will be the internal area plus the external area, that is 2 pi r square plus 2 pi r square. So 2 pi outside in the bracket small r square plus capital R square. Now the total surface area will be curved surface area plus the area of the base, that is 2 pi in the bracket r square plus r square plus pi capital R square minus small r square. We simplify this to get pi into 3r square plus r square. I hope you have followed this topic very well and practiced this topic and get full marks in the ICSE board exams.